Why, hello there.
Hi, Elizabeth.
What are you doing on this fine day?
On this beautiful day, I'm about to blow some bubbles.
How convenient. Bubbles are my specialty. I'm going to explain to you why bubbles are always round, how bubbles maintain the smallest possible surface area, what happens geometrically when two bubbles meet, and how soap helps stabilize bubbles.
Oh my God, Elizabeth, did you just say geometry?
I did.
I'm learning about geometry in school. But all I know is what my textbook tells me, which is that the surface area of a sphere is 4 times pi r squared.
That's a good basis for all the stuff I'm about to teach you today.
Yay! Let's get started!
Do you ever notice how bubbles are always in a spherical shape?
Yeah, bubbles are always round.
Well, that can be explained by this table. This table shows that a sphere will always have the smallest surface area for a given volume, and therefore it always minimizes surface area, which is what a bubble does.
As you can see, a sphere will always have the smallest surface area for a given volume.
That makes sense. But why is this so interesting?
Because the minimizing surface area makes bubbles unique from all other objects.
Oh! I get it! Bubbles will always be in a spherical shape because bubbles will always minimize surface area. And since spheres have the smallest possible surface area for a given volume, the shape it takes will always be that. But Elizabeth, what happens when 2 or more bubbles meet?
Well, a quite interesting thing actually happens. When 2 or more bubbles meet, as you know, bubbles are always going to try to minimize surface area. So when 2 or more bubbles meet, they're going to always try to form a shape with the smallest possible surface area. And they'll combine at a common wall.
But will this common wall always be a straight line?
Not always. If the bubbles are the same size, then the common wall will be flat. But if the bubbles are different sizes, then the smaller bubble is going to merge into the larger bubble, and the common wall is going to be curved, like here.
Oh! But what happens when 2 or more bubbles meet?
Well, if three bubbles are being merged, no matter what the size, they will always meet at a 120-degree angle. But if 4 bubbles are being merged, they will always meet at a 109-degree angle. This explanation comes from the double slope bubble theorem.
Jeepers, did you just say theorem? We learned about that in geometry.
Yeah, bubbles are very related to geometry. Next, we have something called the Marangoni effect, which basically says that contrary to previous belief, when soap is added to bubbles, it does not strengthen them, it simply stabilizes them.
Wait, what?
Let me try to summarize this effect for you. The Marangoni effect is a mass transfer during interface between 2 fluids, such as the common wall and the 2 bubbles, due to the surface tension gradient. As a soap film stretches, the surface concentration of soap decreases, which causes the tension to increase. In this way, soap works by selectively strengthening the weakest parts of the bubble, preventing it from popping.
Oh, that's why soap bubbles don't pop as easily as bubbles without soap. Before, the soap helps prevent popping.
Exactly.
Oh, thank you so much, Elizabeth. I learned so much about how bubbles are related to geometry.
It is my pleasure.